Hi, welcome back. Now we're looking at Fire Dynamics Section 4. Section 4, the learning outcome is to explain the significance of a flow path to the growth of a fire. Specific objectives include defining a unidirectional flow path, defining a bidirectional flow path. Given a visual example, we'll be able to identify a bidirectional flow path, and given a visual example, be able to identify a unidirectional flow path. And given two visual examples of a structure fire, compare and contrast the fire's interior. We'll start with fire spread. So what accounts for fire spread? Conduction, convection, and radiation facilitate the transfer of heat energy, as we discussed in the last section. However, this largely applies during the initial growth phase of the fire, when it's still within its compartment of origin. Initial fire growth is primarily direct flame spread across the first item burning. Conduction, convection, and radiation then begin to spread the fire to other objects or materials within the room of origin in its growth phase. The products of combustion are elevated in temperature in comparison to the surrounding air. And at higher temperature, less dense fire gases and smoke rise, which is called the fire plume. In structure fires, this initial fire plume is redirected across the ceiling, which is called the ceiling jet, which we see pictured here. Once walls are encountered, the smoke is forced downward, and a fire's upper layer is formed. We also see air entrainment below the initial ceiling jet, drawing fresh air towards a fire. Now we're inside a building. In real life it's very difficult to see that air entrainment. You may feel it in terms of the air going by you, but sometimes not perceived, but it is there. So what is a flow path? After the fire is spread within the room of origin, its future spread throughout the structure is based on the fire's flow path. An active flow path can take the fire from the room of origin and rapidly spread it to previously uninvolved portions of the structure. So a flow path is defined as the volume of air between an inlet and an outlet that allows the movement of heat and smoke from the fire area, which is high pressure, towards lower pressure areas, which are other parts of the structure, or outside, via windows, doors, or other openings. Those openings could be created by civilians who open doors, firefighters who break windows, or it could be the fire itself that creates those openings by burning a hole through the roof, or the heat causing a window to fail. Any structure with a working fire where significant heat is present is a pressurized structure. In a structure fire, the method by which a fire that is growing receives the needed oxygen to sustain itself is through one or more flow paths. If no flow path is available to the fire, it may become ventilation limited, as we discussed in earlier sections, and it would go into the decay phase of fire. Flow paths can be categorized as unidirectional or bidirectional. Flow paths from within the structure fire are dynamic, meaning they can change as the fire grows or change due to action taken by firefighters. As mentioned, ventilation techniques such as opening a door or breaking a window or cutting a hole in the roof, those things could all cause the flow path to change. So this is a unidirectional flow path. Unidirectional flow path is air being drawn in on one end, with the products of combustion being exhausted on the other. The unidirectional flow path is characterized by covering the entire opening side to side, top to bottom, as we see pictured here, with flame, smoke, or both flame and smoke. But it's the entire opening that is exhausting. So it has a unidirectional exhaust, as we see pictured here, but it also has a unidirectional intake, which means there's, in this picture, we have fresh air being drawn into that room. So unidirectional flow paths require an intake of fresh air on one end and an exhaust on the other. And so we're always going to have both an intake and an exhaust on a building with a unidirectional flow path. Inside a structure that has a unidirectional flow path, between the fire and the outlet is a very dangerous place to be, even for firefighters in full protective gear. The space between the fire and the outlet has high temperatures, high velocity, movement of heat and smoke with zero visibility. The velocity of the hot gases leads to incredible levels of heat flux. The way I explain this to most people is to think about it as a convection heating in an oven. Right? If you bake under convection heating, basically it's taking that hot air and moving it around, blowing it around, and it's that velocity of the hot air that leads to higher levels of heat flux. Then we have bidirectional flow path. A bidirectional flow path exhibits the products of combustion moving out and air in along the same flow path or opening. So here we have the seat of the fire, heated gases moving out at the top, and fresh air coming in at the bottom. This is what it would look like at a residential structure fire. So this is very common for firefighters to work within this type of flow path. Bidirectional flow path, although very dangerous, is more tenable to human life than the unidirectional flow path. The bottom portion of the bidirectional flow path includes fresh air being drawn in and towards the fire, and thus lower temperatures. But we should note that conditions are subject to rapid change within any structure fire. What is a bidirectional flow path could very quickly become a unidirectional flow path, especially due to changes in ventilation. In conclusion, a flow path is the volume of air between an inlet and an outlet that allows the movement of heat and smoke from the fire area to other parts of the structure or outside via windows, doors, or other openings. A unidirectional flow path has air being drawn in on one end with the products of combustion exhausting on the other. Bidirectional flow path exhibits the products of combustion moving out and air in along the same flow path or opening.